I'm G. Lohit from SRIT and studying the second BTech Mechanical Engineering. And today I want to explaining about the one of the topic in thermodynamics called various thermodynamic processes. And so you can go for the mainly first what is mean by introduction of thermodynamics. So thermodynamics is a subject which deals with the heat and energy and the forms of energy, and we can understand by the thermodynamics what is the behavior of metals and heat and work transfer, and it provides the foundational principles that govern the behavior of the system of thermal equilibrium. Understanding the thermodynamics is essential analyzing energy transfer in the various applications. So we can go through for the next. So there are the many topics in the thermodynamics, many processes like first law, second law, third law, and isothermal process, and reversible process. There are the lots of processes, so we can deeply discuss about these processes. So firstly, first law of thermodynamics. The first law of thermodynamics that change the internal energy of the systems equals to the heat added the system minus to the work done of the system. The law states that basically this law states the law of conversion of energy. So one type of energy converts into the another type of energy. So this process we can explain by the first law of thermodynamics, and it has expressed the mathematically delta U equals to Q minus work is called internal energy minus heat minus work done. So you can where delta U equals to change of internal energy. The second law of thermodynamics. The second law of thermodynamics introduces the concept of entropy, starting the neutral processes to increase the total entropy of the system. It implies the energy of the transformation are not 100% sufficient. Some energy will be lost of the waste heat. This law explains the directionally thermodynamics process indicates the energy is depresses over time. So second law of thermodynamics states that the 100% energy not converted into heat, there is the some amount of waste of there is a sum of amount of waste of energy. This states that second law of thermodynamics. And third law of thermodynamics, the third law of thermodynamics, the law states that temperature approaches absolute zero, the entropy of the perfect crystal approaches zero. The principle set the reference point for the determination of absolute entropy values, and it implication of understanding the behavior of materials and the low temperatures. And the next process one is isothermal process. An isothermal process occurs the constant temperature, implying the heat and exchanged with the surroundings. In this process, the internal energy of an idea remains the constant, and internal energy of the function temperature. Examples including the expansion of compression gas in the piston at the constant temperature. So basically isothermal process is telling that the constant temperature implying on the heat and the heat exchanged with the surroundings. In this process the internal energy of ideal gas will be remain constant, the internal energy function of the temperature. So in this case of scenario they are telling us like the internal energy of ideal gas will be remains constant, including the expansion of compression in the piston. It will be also a constant temperature. Next, adiabatic process. Adiabatic process occurs without the heat transfer between the system and its surroundings. In this process, internal energy change due to the work or by the system. In this process, there is no transfer of heat to the surroundings from the system. There is no transfer of heat to the surroundings, and the internal energy change due to the work done by or the system. It is characterized by the rapid change in the pressure and temperature, such as the gas compression. So we can see the formula there. PV gamma equals to constant. Irreversible process. Irreversible process can be written as initial state without net changes in the system. It serves the idealization of thermodynamics and provides the benchmark of the efficiency, and real processes often irreversible due to the friction, turbulence, and other dissipative effects. And there is a steam calorimeter overview. This is the steam calorimeter method used to measure the heat vaporization, other thermodynamics properties of the steam. It involves the use of calorimeters to determine the energy transfer due to the phase changes. The technique is essential for the applications whereas such as power generations. So this is calorimetry. It is used to measure the temperature of the vaporization form of liquid, and it is used and the calorimeter determine the energy transfers of the phase changes. Okay, you can see over picture there. You can see picture there. There is a oxygen atmosphere, thermometer, stirrer, and ignition. By these components using, we can measure the temperature. And there is applications of calorimeter and steam calorimeter widely used in the design of steam turbine and steam exchangers. It it mainly help us to determine the efficiency of the power plants and optimizing the thermal cycles. The database can useful for the material testing and safety assignment. And limitation, there are when there is advantages and there are also some disadvantages are called limitations of calorimetry. One of the limitations, assumption of ideal behavior may not hold true. The precision of measurements can be affected by the heat losses to the environmental. Okay, next, by these I can conclude that understanding thermodynamic processes and steam calorimetry vital for advancing for systems, and future research may be focused on the improving measurement of techniques and efficiency energy. The principle of thermodynamics will be continue significant role in the addressing global energy. So these presentations covers the overview of thermodynamic processes, and I hope you can understand what I am saying in these processes. And thank you. Have a nice day.